Well, apparently the Gateway to the West Arch in St. Louis can be modeled by this parabola. Now notice it's a parabola, right? It's squared and it's negative, so this is a parabola that opens downward, right? It's going to look like this. Here's the ground. Oh, I can do better than that. Here's the ground a little bit more level, and here's that arch. And what we're supposed to do is sketch. I don't think I'll do that. I'm going to go to write the part B. Approximately how far do you have to walk to get from one side of the arch to the other? So what we're looking for is, if we're over here, how far do we have to go to get over here? I pulled in a graph from Desmos. I like to use Desmos. It's very easy to use, it's free, and it gives you a nice graph. So here's the arch. So what we're going to do is we're going to write that as our x-axis. Our y-axis will be right over here. Here's the 0. So what we want to do is find out how far do we have to walk from here to here, right where it intersects and intersects here. Well, it seems what we're looking for is back in this original equation, we want to get this point as well as this point. Well, this point here on the graph, you can see that one is 0, 0. And sure enough, if you put 0 in for x, what do you get back? You get back y equals 0. Now, does that give you an idea of how to do this one? I mean, we get an approximation by the graph, but we don't know exactly what that number is. But here's what we do know. Like we knew over here, when x is 0, you put 0 here and 0 here, what do you get back? You get y equals 0. And y is what? Y is the height of the arch. So right at x equals 0, the height is 0. So what do we want over here? Well, as we walk, you can see the arch, the height is increasing, 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 hits the max, and as we keep walking, it decreases, 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 until finally we get to this point when the height is 0. So what we want in this case is, oh, that's a terrible color, we want y equal to 0. So let's set that into our equation. Now I'm going to write our equation again. Y equals negative 1 over 150x squared plus 21 over 5x. And we want y to be 0. So negative 1 over 150x squared plus 21 over 5x. An equation that involves rational expressions, fractions. Let's get the LCD. So the LCD here is, both those numbers go into 150. So I'm going to multiply all 3 terms by 150, and that'll eliminate all the denominators. So this is going to be 150 times 0 equals 150 times negative 1 over 150x squared plus 150 times 21 over 5x. Right? You remember when you solve rational equations, you get the LCD, which is 150 in this case, and you write that in front of every original term. Now, on the left side, 150 times 0 is 0 equals, and over here, the 150s cancel, and you're left with negative 1 times x squared, or just how about negative x squared. And then here, what do we have? Well, 5 will go into 150. 5 into 15 is 3 and another 0. So we're going to have 31, so plus 30 times 21x. Let's simplify that. We'll get 0 is equal to negative x squared plus, now 3 times 21 is 63, but we have a 0 there. Now we can solve this equation by factoring. I will do it up here. I'll get 0 is equal to, I'm going to factor out a negative x. And if I take out a negative x, I'm left with what? Positive x and then minus 630. From which we will get 0, and from here, 630. There's our x. And sure enough, if you look back over here, x is 0. That's your starting point. And 630, follow it over here. That looks about right, right? That says 600, so 630, that's about right. So how far do we have to go? We have to go 630 feet minus 0 feet is 630 feet.